Okay, so what you're going to do is go to the website that I sent you on Remind, geogebra.org/groups. It may serve you well to create a GeoGebra account prior to this step. I've had a GeoGebra account for as long as I can remember, so I honestly don't know if it's going to take you where you want to go if you don't have an account already. So if you're nervous about it, just go to geogebra.org, create your account. I link mine up to Google, so it's very easy to create the account and go from there, right? But once you have an account, then come here and go to geogebra.org/groups, type in the code that I gave you on Remind, which may or may not be this code. All right, this is from a particular course. All right, so then select Join. All right, so once you do that, I'll hit Join. I think I'm already joined. Oh, okay, so I just rejoined. So once you do that, it brings you to all the tasks associated with that particular account. All right, or I'm sorry, that particular group. So you're working on, for Tech Assignment A, Area Under the Curve Parts 1 and 2. All right, eventually there'll be a Tech Assignment B up in the same group. All your tech assignments are going to be in this area. That's new for this semester. All right, click on that little notebook-looking thingy, and it'll bring you to the first activity, all right, which looks awesome. All right, so it didn't quite look the way I wanted it to, so I'm just going to hit start over. I'm going to hit restart. If you're presented with a blank screen, and I guess I'm going to hit every single problem along the way here, which is good because then you can see how I troubleshoot it. The other thing was not a word. All right, so if you run into a problem with a particular applet, just hit that little restart button. It may be annoying, especially when you get to the spreadsheet part, but you'll be able to start fresh. All right, so here automatically there's a function y equals x squared. It's just written as function equals x squared. But what's happening is, as I toggle back and forth along this slider, it's giving me the accumulated area from 0 to that particular number. All right, and so what we're going to do is play around with this a little bit, get a feel for it, and then scroll down. And you don't really need to see the graph anymore. It's really just this stuff because the B value corresponds with the area. Right, the capital A and capital B values here correspond with the lowercase a and lowercase b values here. Couldn't figure out how to make them coincide, so we're just kind of living with that. All right. So what I'm going to do is type in some ordered pairs, some A values and the corresponding areas. All right. So whenever you're investigating graphs, it's always a good idea to have an array or a variety of values. So I'm gonna throw in some negatives. I'm going to try to get 0 in there because 0 is a nice number, and some positives. All right. So the one thing I don't want to do is when I input a value into a cell, I don't want to hit enter. I honestly have no idea why this is an issue. I just know that it's an issue. And if you do, you're going to find yourself hitting restart very frequently, not frequency. So I'm going to click in the cell I want. I'm going to type in negative 1.5. Then I'm going to click in the adjacent cell and type in negative 1.125. All right, that's the corresponding area. So that's locked in. It automatically rounds it. You should type in as much as you can of the original decimal. Let the software round it for you. Let's see. How about something relatively clean? Oh, there we go. Negative 1.8. Click negative 1.944. Don't hit enter, just click. All right. Let's get 0, 0, 0. All right. So, sometimes I've noticed this. If I'm in the cell already and then I start moving the slider and then I just start typing, sometimes it gives me issues. So I click out of the cell and then go back in. I know it's weird, but better safe than sorry. All right. Now, you'll notice here for this particular situation that you can rely on symmetry because I'm going to try to get to 1.8, and you'll see that 1.8 corresponds to positive 1.944. So really, you actually already know the remaining values. So I'm going to type in 1.8, 1.944. All right. I'll actually just not prove it, but I'll demonstrate it. I'll go to the 1.5. You see that's 1.125. So 1.5 and then 1.125. All right. So just click into a cell. All right. You can go to an empty cell if you want, but you don't need more than 5 data points because this formula only calls for 5 data points. If you do more than 5 data points, it's just going to ignore the rest. So it's wasting your time. Now, this is a regression model, a polynomial fit depending on what the A value is. All right, so I'm going to scroll down a little bit. I created a slider to address the particular A's. Now, one thing I'm still working on is to make A only increase by an increment associated with integer values. So decimal values for A don't really make sense when you're talking about polynomials, because if you have a fractional power, you're not dealing with a polynomial function, you're dealing with a rational function of some kind, or even a radical function. All right. So, but what I'm going to do is take note of my R square value. R square represents, if you remember from statistics, it's the coefficient of determination. It's associated with a correlation coefficient. What it tells you is the strength of the relationship between two variables. All right. So the closer it is to 1, the closer it is to a perfect fit. So I'm going to slide over to the right until I get to the very first instance in which I can look at the graph and see when the curve actually goes through all the points for the very first time, or when my R square value hits 1 for the very first time. All right, not quite there. Now all of a sudden I'm there. You can see in the graph, it hits it perfectly, goes through all the points. My R square value is equal to 1, and it's generated an equation with that. Now if I go further, it's still 1. Well, until it's undefined, until it's not 1, basically. But I want the very first instance in which it hits 1. All right. And so that is the equation of the curve that best fits the data set that we just generated by playing around with the sliders. All right. So what I want you to do is think about what just happened there. All right. And then type your answer in the field here. All right. And so at that point, you can click turn in. You know, I mean, I would recommend that you kind of verify, or at least really consider your answer before you submit it, because, you know, this is something that you're submitting for a grade. All right. So carefully consider why things are working the way they are. Once you do that, click over into the second part of it. In this activity, very similar. The only thing you're going to do, I put in a new function here. It was originally x squared. I can hit restart. Beep. Yeah, sure, I want to start over. Create a unique polynomial function with multiple terms and a degree higher than 2. All right, so that's got to go in the field. So, well, power of 2 isn't going to cut it anymore. I want a power of 3. So let's see. Or power of 3, power of 5, power of 13, it doesn't matter. Just something with a power higher than 2. All right, so degree higher than 2 is very important here. And it has to have multiple terms. Multiple terms could be 2 terms if you want. It could be 10 terms. All right, so let's see. Let's go x cubed. By the way, a little nifty shortcut. If you hit the Alt key and then the number that you want, it automatically makes that number into a power. Let me do plus 3x squared. I'll just leave it at that. Keeping it simple. All right, creates a cubic function, and now I'm just going to do the same exact thing I did before. Play around with my slider. Do not steal my example. If you do, that's the quickest way to not get any credit for this part of the activity. All right, so come up with a unique function, something that you yourself created. Now, it could be a minor tweak to mine, but the issue is if you make a minor tweak to my function, odds are there are other people that are making minor tweaks to my function. And what could happen is, let's say if you change this from a positive to a negative, there's probably like 3 or 4 other people who are thinking the same exact thing. What am I going to think when I'm grading these? I'm going to think you cheated off each other. So don't do that. Just try to come up with something unique. All right. So collect your data, 1 against 1.25, put it in the table the same way you did on the previous page. Take note of what your function is, and then scroll all the way down Explain how these activities justify the connection between a function and its antiderivative. Be explicit. All right, so give great detail. No simplistic answers here. All right, this is a take-home assignment. It's designed for you to put a lot of thought into it. All right, and then once you do that, you hit turn in, and I'll have access to your work. I have the ability to lock you out of your assignment. Once I decide, generally once the deadline hits. But what that means is until I lock you out of the assignment, you have the opportunity to continue editing it. All right, so you can go back in, even if you hit turn in. All right, so just keep that in mind.